1.1d, integers and absolute value. The integers include whole numbers, 0, and negative numbers. We can think of negative numbers as a reflection of the whole numbers over 0 on a number line. So we drew a number line out here. We had 0 here, and the whole numbers 1, 2, 3, extending forever. If we just reflected this line over 0, we have the negative numbers. So -1, -2, -3, and so forth, extending this way. The absolute value of an integer is its distance from 0 on the number line. So we denote absolute value with these line symbols with a number in between. So that would be the absolute value of 3. Let's go through a couple examples involving integers and absolute values. So the first example, simplify -1. So let's think about this. This means a reflection of -1 over 0 on a number line. So let's take a peek at a number line. Let's just draw one out real fast. -1, 0, 0. So if we reflected -1 over the number line, take the negative of it, it would just be +1. So -1 equals 1. Great. So here's another example. Simplify negative absolute value of -4. So for this example, we have to go back to the definition of absolute value, which is it's an integer's distance from 0 on the number line. So again, let's draw another number line. We'll draw -4 on there, and we'll draw a 0. So the distance of -4 from 0 on the number line, if we were to walk from -4 to 0, this would be 4 away. So the absolute value of -4 is 4. But we have to remember to take the negative of that number, right? Because we're doing negative absolute value of -4. So our answer is just -4. A quick rule to remember absolute values is an absolute value always turns numbers positive. So there's a quick rule. So if you have an absolute value of a negative number, it's always positive. If you have an absolute value of a positive number, it will just stay positive.